let's just go back over the SpongeBob example we had. And so the SpongeBob example we had, U is Bikini Bottom residence. We had A would be residence, SpongeBob Street. We had B was Krusty Krab employees. And we had D was aquatic animals. And we were looking at what is A complement union B complement minus D complement. Is that what it was? Yeah. So we had that right here. And before we come with this really complex situation, we were trying to think about what all this meant and stuff like that. But set identities makes this easy. Now we can almost just basically do like, almost just like arithmetic on set. This is basically set arithmetic. We're going through and just kind of simplifying things and stuff like that. So what I'm going to do here is the first thing I'm going to do is I'm going to recall that if you subtract, if you do a set difference, that's the same as intersecting with the not. This is by number 12, the set difference law. This is going to be A, same thing as A complement union B complement, intersection, not what you're subtracting. And this is by set difference law. So that complement there. But then A complement union B complement, if we have a complement of a complement, this is just D. They cancel out basically. And this is by double complement law, just like double negative law. Or double negation law, whatever it's called. And then we move down. What did you do from here, Herman? We're trying to simplify this.
Yeah, I probably used De Morgan's, right? I think you used De Morgan's on that.
Yeah, you can actually use De Morgan's law in two places here. So would you use it on kind of distributing this complement to here and here?
Sure. I mean, that'd be good.
You could also do it here. So it's that AC union BC. Hey, that's the same thing as A intersect B complement. You kind of run De Morgan's law backwards. But,
oh, yeah, I see. There's also absorption law, right? On the.
Yeah. Actually, we could distribute the D. Absorption law, you have to be careful because that uses like the same. This is A intersect, A union A intersect B.
I see. Yeah.
A here twice. That's what makes it deal with subsets and things like that. But anyway, this is going to be A, C, union B, C. And then we'll have a complement, union D complement. Because we flip the one in the middle and we distribute the complement. But then here, I think we can use De Morgan's law again. This will be A complement, intersect B complement, union D complement, distributing the complement, flipping the sign in the middle. And then quick little double negative law. Oh wait, we should mention this is De Morgan's law. By De Morgan's law, by De Morgan's law. And this is, so now we're going to do double negative law twice here. There we go, like that. And then I think this is basically as simple as we can get it. So let's talk about what this means. So A are the residents of SpongeBob Street. And the residents of SpongeBob Street, that's just SpongeBob, Squidward, and Patrick. B is Krusty Krab employees, which is just SpongeBob, Squidward, and Mr. Krabs. And then D is aquatic animals. If we take the complement of that, there's everyone that lives in that's everyone that lives in Bikini Bottom that's not an aquatic animal, which is just Sandy, a set of Sandy Cheeks. And then we'll put these together. The intersection, like the shared elements between SpongeBob, Squidward, Patrick, and SpongeBob, Squidward, and Mr. Krabs, is just SpongeBob and Squidward. There's a union that with Sandy Cheeks. And this is just going to equal, well, SpongeBob, Squidward, union Sandy Cheeks, that's just SpongeBob, Squidward, Sandy Cheeks. And here I'll just say, by definition of the sets. This is by definition of intersection. And this is by definition of union. So we get the same answer, and we have more lines, but I would argue this is easier than what we did before because we didn't have to think about it. Like what we were doing before is we were kind of almost every step of the way proving these little things that we were doing, rather than just saying, oh, it's been proven, let's just do some arithmetic. So I think this is easier, personally. What do you think, What do you think, Herman?
Yeah, no, it's much easier.
I don't know if you agree. I don't know if I just mean agreeable or not, but I like it. But anyway, so that'll be class for the day. Thanks for coming. Any questions?
No, all good. Actually, I guess I do. Are the office hours the same? Have they changed? I saw an email about it, but I didn't take a look.
Oh, sorry. I'll probably email right after this, but I'll probably give you the same answer. That is, no, office hours are exactly the same for this week. We have Tuesday, Thursday, so Tuesday's already gone. So we have Thursday office hours. Tomorrow, just like usual. Next week, next week they're going to be the same again, I plan on having Tuesday office hours from 9 to 10 like usual. And then Thursday office hours, maybe a little longer. And that'll be like, it's reading day. So it'll be like, if you want to come in, shore anything up, get your last or decide mulligan in, like ask me any questions. It'll be like a little AMA. Well, it'll be an AMA MR. Ask me anything math related. But yeah.
Cool. Okay. Well, thank you.
You're welcome. Yeah, see you later, Herman.
Have a good one.
Thanks for coming. I'll not be alone.
Yeah.